Hello everyone. Now in this session we will know about the concurrency control in a distributed database. In a previous session we already understood about distributed transaction, then the basic about the distributed transaction, failure modes, and the use of commit protocol to define the particular transaction is committed or abort under the distributed database with a distributed transaction. Now we will know about the concurrency control in a distributed database. We already know about distributed database means it's run with the replica of the database, and then a particular transaction update any value, we need to maintain that replica also as a database, as a consistent database. Now for that purpose, with the commit protocol and the concurrency control, we need to implement the process to maintain the database atomic, or it may be a consistent. That is, every website have a contribution with the commit protocol for global atomicity. Means if we think about the commit protocol, every website is related to that, and after that it decides the particular transaction is committed or not. Protocol will maintain the data consistency with the all website. This one is only a short note about this explanation. The protocol will maintain the data consistency with the all website. Now what exactly method to maintain the concurrency control in a distributed database? Now the first solution, that one is the locking protocols. That one is lock manager, that will only change that need to be incorporated in the way the lock manager deal with the replicated data. Definitely lock manager, which one is maintain that replica, but maybe just when the particular transaction update the data, then the every replica will update with the, but maybe not a multiple transaction work on a particular single value, and it may be a run with the inconsistency. That's why the lock manager will deal with the all replicated data. Now the locking protocol, that one is a simple or the first way, that is single lock manager approach. Then locking protocol have a different type of approach to maintain the atomicity with a distributed databases. Now in the single lock manager approach, then why we need to maintain the concurrency control, or why we need a concurrency control, why we need to a locking protocol? That one is a simple example. Under the distributed databases, if we store the data, this is the one website, then this one is another website, then this one is a third website, we can say that, and which one is maintain the particular databases, right? It's a replica of the databases, we can say that, and the multiple website which one is access that data, right? That one is D, or it may be any combination, or it may be any way they can access the particular data with a given replica. Now this one is a distributed system. Now if A want to update the value of a particular atom, right, that one is stored in this replica and in this replica, then how exact that consistency is maintained with the help of the locking method or the locking protocol? Then it contains a different type of ways. That single lock manager approach. In a single lock manager approach, system maintain a single lock manager that reside in a single chosen site, says SI. That one is, it maintain the all the locking process by this website, that is, we can say that SI, right? Means this one is the main website which one is maintain the all locking mechanism. All lock and unlock requests are made at the site of SI. Means any transaction like a T1 or the T2 which one is generated by the any website, the SI means a website manage all the locking unlocking processes. That is the concept. Now the transaction can read the data item from any one of the site at which a replica of data item resides. Reading is not a problem. In case of a write, all the sites where a replica of the data item resides must be involved in a writing. Means if the particular we want to update the data in the consider as a C site, right, and the replica of that under the B and the A also, then we need to maintain the 3 replica. That one is under the A, B or C, right. That one is done with the at the time of writing. Now the scheme has this advantage with a single locking manager, simple implementation. That one is only a one website manage all the locking unlocking on a particular data and inform to the all the website where the particular replica is stored. Now the simple deadlock handling, all the lock and unlock requests are made by at the one side. That's why deadlock handling algorithm can apply directly. We can apply the deadlock handling algorithm in a particular that that site where exact the locking mechanism is available. Now the disadvantage, bottleneck is created because of the all the particular sites send a request to the A to locking on a particular data, right. All the site send a request to the A. That's why the bottleneck at the A site, that is a disadvantage. Vulnerability, if the SI fails, the concurrency control is lost. If the particular A is maintained all the locking unlocking and this A website fails, then it may be again a problematic situation. That one is simply the single lock manager approach with the advantage and disadvantage and the concept. Now the second approach, that one is a distributed lock manager. In this approach, only one website have the locking management system. Now the distributed lock manager, what exact the concept with this? The compromise between the advantage and disadvantage of a previous method, the distributed lock manager approach. Lock manager function is distributed over the several sites. Means not a single site run with the locking system, lock management system. It may be the out of consider we have the 4 site. In the first approach, only one website manage the locking. Now the second approach, it may be a more than 2 website out of 4 is maintain the, or we can say that half of the website maintain the locking management system, and the all that locking management or the locking manager which manage the consistency. Now the local lock manager whose function is to administrator the lock and unlock request for those data item has that are stored in that site. Means a local management or the particular distributed lock manager, it's a lock manager function is distributed over the several site, not all site. Then the local lock manager whose function is to be administrate the lock and unlock request for those data items that are stored in that site. If the particular this is the lock manager, this one is also lock manager. If we want to update this data or apply the lock on this website data, then this local lock manager will manage all the things for this data with the help of other website. Now the another scenario, when the transaction wishes to lock the data item Q that is not replicated and reside at the SI, means which one is not a locking lock manager available on that website, and the particular data is updated on a particular website, then message is sent to the lock manager at the site SI requesting a lock, right. That one is all the other locking means this is the website want to lock on a particular this website data, then it send a request to this 2, then this 2 manages this locking system, right. That one is if data item Q is locked in an incompatible mode, means that one is not available for the accessing, then that permission is delayed, and once it is available it gives a grant to the access it, or the lock manager send the message back to the initiator indicating that it has granted the lock request. Means it may be a this side is sending a request to the this to log manager for this data, then it may be it's available, then it gives the permission to this, and the particular site can access that data, and this two site maintain that concurrency process. This is the distributed log manager. In this mechanism, only one log manager is available. In this, it may be more than one log manager is available. Then what is the advantage if one of the is failed, one of the log manager website is failed, then another will manage it. Now the third is the primary copy. When a system uses data replication, we can choose one of the replica as a primary copy. Means out of the let's have the multiple copies. Out of this 4, one is the primary copy, right? This one is the important. Everything will be a reflect with this copy, right? Then for each data item Q, the primary copy of Q must reside in a precisely one site, which will be called as a primary site of a Q. When the transaction need to log a data item Q, it requests a log at the primary site for site of a Q. For responding, the request would delayed until it can be granted. Primary copy enables a concurrency control for replicated data to be handled like that for unreplicated data. If the primary site of Q fails, Q is inaccessible. Even through other site containing a replica may be accessible. That one is again generate the inconsistency. Means a primary copy which one is easy to maintain, but if it is a fail, then it may be a problematic. This is the primary copy concept to maintain the consistency, or we can say that to maintain or to implement the concurrency control. Now the major protocol is again the major protocol work this way. If data item Q is replicated in n different site, then a lock request message must be sent to more than one half of the n site. That means simply the if 4 replica is available, then half of means n is a 4 and n divided by 2 means 4 divided by 2. Two website contains a authority to maintain the locking request, right? Each lock manager determines whether the lock can be granted immediately. As before, the transaction does not operate on a queue until it has successfully obtained the lock on a majority of replicas of a queue. For example, T is a transaction which one is send a request, or the X have the replica on the 3 website, right? T send a request to the this 2 and he get the access out of 3, he get the access on a 2. Then transaction T can update the data of X, right? This is the one scenario. If replica of X is on the 4 site, then T send a request and it's got the permission from the 3 site, it's allowed to access the X again, right? This is simply the concept of a majority protocol. Means a majority of a website which one is gives the permission to a transaction T to access the X, we can say that. Now the major benefit of the majority protocol is that it can be extended to the deal with the site failure. Means if the particular this site fails, then the other side will manage the things for the particular transaction, right? Or this side fails, the other will manage the things. Now the suffer from this disadvantage. This majority protocol have the problem disadvantage. Then the majority protocol is major complicated to implement than R2 previous scheme. It is difficult because of required at least 2 into n by 2 plus 1 messages for handling the lock request. This is the message count we need to send to the particular sites to the handle the lock request. Then the n by 2 plus 1 messages for handling unlocking request. This is the mathematical equation which one is we need to send the messages at the time of implementation. Then deadlock handling, problem of a global deadlock due to the use of distributed lock manager approach. For example, suppose that transaction T1, T2 wish to lock the data item Q in an exclusive mode. Exclusive means that one is for the writing, right? Then T1 maybe a succeed to locking, means for example its content, how exact the deadlock will happen under the majority protocol. It's a T1 X is available with all replica, then T1 get the permission from this and this, and T2 get the permission from this and this. Now both T1 have a count of a 2 and T2 have a count of a 2. Then which one is the majority? It's both are equal. Then it's again a deadlocking situation, to which can get the access on X, T1 or T2, right? This one is simply the deadlock handling. Here the solution for the deadlock handling is predetermined order. We need to define the order. If this is a 1, this is a 2, this is 3, this is 4. If T1 get the access on a 1 and 2, then T will just to get the permission on access the X. If this T1 get the access of 1 and 3, he will not access, or it may be whatever the sequence. This 1, 2, 3, 4 is the final one, sequence is the final one. Then as per the sequence, it will T1 will be a get the access. Then as a 1 and 2, then T1 is allowed to access the X, not a T2. That is the predetermined order, right? To handle the deadlock handling. That one is under the majority protocol. Now the last protocol, that one is biased protocol, is another approach to handle the replication. That one is simply the shared lock manager at the one side. For the shared locking, one website manages all the shared lock, right? And the exclusive lock manager at the all side. That one is a biased protocol. Means in previous protocol, it's only it may be a single side, or it may be a half of side have the locking mechanism or the manager. But biased protocol, shared lock managed by the local lock manager at a one side, means a single side manage all the shared lock, and the exclusive lock means a read write process. That one is managed with all lock manager at the all side, means all side have a lock manager and it manage all the exclusive lockers. That one is a biased protocol. This one is simply the some protocol which one is maintain the concurrency control in a distributed databases. In the next lecture, we will know about the another method to maintain the concurrency control. That one is a time stamping. Thank you.